Hey everyone, welcome back. This is episode 5 of Build a Full-Stack .NET Multi-Tenant CRM. And yep, we're diving deeper today. Things are getting exciting. In this episode, we're going to add token-based authentication to our solution so that our Blazor web app can securely talk to the API. No more unsecured calls. It's time to give our system some real protection. Then, we'll use that token to let the user upload their profile picture. Yep, finally some faces in our app. After that, we'll update the user info in the database. And to wrap things up, we're going to build the feature to change the password. So yeah, it's a pretty packed episode, and we've got a lot to cover. Alright, before we jump into the code, let me quickly walk you through how the token generation and usage flow works in our solution. We've got a full circle here, from login all the way to sending authenticated requests. It all starts right here, the login page in our Blazor web app. The user enters their credentials and hits the login button. That triggers a call to our internal service, specifically the login async method inside our authentication service. This service sends a login request to the API. The API project catches that request in the authentication controller, and then it forwards the job to the service layer, where the actual authentication magic happens. In the service layer, we call the utility project, and inside that, we use the generate JWT token method to create our token. In this episode, we're focusing on the access token. Later on, we'll add a refresh token to the app, so it can automatically retrieve a new access token when the current one expires. The token gets sent back to the service layer, where it's attached to the user object. Then the API sends the whole package, the user object plus the token, back to our Blazor internal service. And this part's important. The token gets saved to local storage, so we can use it later. Finally, whenever we want to send an authenticated request, like updating the user profile, we just grab that token from local storage and stick it into the request's headers as a bearer token. That's the full flow, from login to secure API calls. Alright, I've broken the work into 4 steps, each focusing on a different layer of the application. You'll also see these little checkboxes here. As we go through each part, I'll tick them off so you know exactly how far along we are and what's still left. Step 1 is all about the token engine itself. We'll implement the token handler, the token configuration, update Swagger, and register everything we need into the API's service container. Step 2 moves into the service layer and API. We'll update the login logic there and add a user service and controller so users can update their profile or change their password securely. Then comes step 3, where we update the login process inside our internal service in the Blazor app. We'll also hook up user-related methods and inject our custom error handling service for better feedback. And finally, step 4 is all about improving the UI. We'll build the user profile page, wire up the services inside the container, and even tweak the snack bar settings for smoother UX. So yeah, a lot to cover, but it's going to be super fun and practical. Let's jump right in and kick off with step 1. We're building this from the ground up. I made a few small changes to the project just to save us some time. Let me quickly show you what I did so you don't miss any steps and the commit order stays clear. As you can see, I've made 4 commits on the episode 5 branch. And for those of you who might not be familiar, you can open this view by clicking on the View All Commits link here. In the first commit, I updated a few models that we're going to need in this episode. Nothing too difficult. We've done similar things in previous parts. I added the token configuration class, similar to the email configuration class we had before, and also added token parameters. We'll go through them together shortly. I also created an interface called iTokenHandler, which we'll use later on. In the next commit, I updated the localized strings, especially the ones we'll need for the user profile page. And finally, I made some improvements to the error display component, the one we built earlier. We'll take a look at that too as we go. Alright, here's the token configuration class I mentioned earlier. This class basically holds all the settings we need for generating and validating JWT tokens. The subject defines the purpose or identifier of the token. It's like a label that helps specify what the token represents. Secret key. This one's super important. It's the key we use to sign and validate the token, kinda like the secret handshake between the web app and the API. If this gets leaked, well, let's just say chaos will follow. Issuer. In our case, this will be our API's base URL. It's like the token's birth certificate, showing where it was created. Audience. Right now it's our web app's URL, but later we'll add our mobile app too. Think of it like a concert ticket. It specifies who's allowed to use this token. Token expiry. Our bouncer that kicks out old tokens. All of them are marked as required, so the app won't even start unless these values are set. That's super helpful because it prevents weird runtime errors due to missing config values. Just like we did with email configuration, we'll store all these values in appsettings.json under a token configuration section. Then, in program.cs, we'll inject these settings into our token handler class during startup, keeping everything clean and configurable. Think of the token parameter class like a little travel bag for our JWT. Right now, it's only carrying the user ID and email to know who the token belongs to. But we're planning to add more things. Soon we'll include a tenant ID to keep everyone's data separate, especially when we have different customers. We'll also add claims, like permission badges, to control what the token can access. I've also added a token handler interface. For now, it just has one method that generates a token as a string from a list of claims. And lastly, I've worked on the error display component. I've made the elevation property dynamic, so we can adjust the shadow size of the mudpaper component as needed. For instance, I've removed the shadow on the user profile page by setting the elevation to 0. These are the changes I've made. Now, let's move on to creating the token handler class. First, I'm going to add the necessary using statements. I need to install the Microsoft Identity Model Tokens package, and of course, I'm going with the latest version. Same goes for Identity Model Tokens JWT, which we'll need for working with JWTs. And while I'm at it, I'll go ahead and remove any unnecessary usings to keep things tidy. Alright, let's take a look at our token handler class. We're generating a JWT, or JSON Web Token, which our app will use to authenticate users when talking to the API. Now this class is using constructor injection to get our token configuration. That's the config class we created earlier, remember? We're injecting it using iOptions token configuration and grabbing the actual values by calling .value, like email sender. Then we've got our main method, generateJWToken, which takes a list of claims. Claims are basically the user's identity info, like their user ID, email, roles, stuff we want to embed in the token. First up, we create a security key by converting our secret key string into a byte array and wrapping it with symmetric security key. This key is used to sign the token. It's like a digital signature that ensures nobody can mess with the token after it's created. Next, we define signing credentials. We're saying, hey, sign this token using HMAC-SHA-256 with our security key. HMAC-SHA-256 is one of the recommended secure algorithms. Then we calculate the token's validity period by adding the number of minutes from our config to the current UTC time. So if your token expiry is set to 60, that token will be valid for 60 minutes. Now comes the actual token creation using JWT security token. We pass in the issuer, audience, claims, expiration, and signing credentials, all the ingredients our token needs. Finally, we use JWT security token handler to serialize the token, basically turning that token object into a nice, neat string that we can send back to the client. And yeah, that's our JWT ready to roll. Now I'm going to add the token configuration values to the appsettings.json file in the API project. You can generate a random secret key using an OpenSSL command. I'll drop that command in the video description for you. The issuer and audience values can stay as they are for now, but we'll update them later when we publish the application. And the token expiry is set to 120, which means the token will be valid for 2 hours. Alright, let's wrap up step 1 by heading over to the program.cs file. Okay, here to register everything we need, I'm going to paste the following code. I need to install the necessary package. There we go. There's an ambiguous reference here between CRM utility.tokenhandler and Microsoft.identitymodel.tokens.tokenhandler. It would probably be a good idea to rename my class to avoid confusion. I might do that later. But for now, I can quickly resolve this by using a type alias at the top of the file. That way, I can explicitly refer to my own token handler without any conflicts. Okay, cool. It is looking good. We configure the token configuration section from appsettings.json file. Then, we register our custom token handler as a singleton service so we can inject it wherever needed. Now here comes the fun part: enabling authentication for the entire app using JWT bearer tokens. We tell ASP.NET Core that we're going to use JWT as the default authentication scheme, and here we configure how the JWTs will be validated. Let me quickly explain some of the important parts here. Valid issuer and valid audience must match exactly what we configured in appsettings.json. Issuer signing key is created from the secret key, and it's what we'll use to sign and verify the JWT. And then we enable all the necessary validations: issuer, audience, signature, and expiration. Clock skew equal timespan.0 means we're not allowing any extra buffer time. The token must be exactly valid. Now let's make Swagger aware of our JWT authentication setup so we can test our secured endpoints right inside Swagger UI. To do that, I'm adding a security definition for the bearer scheme. This tells Swagger how to expect our token in the request, in this case, as an authorization header that starts with the word bearer, followed by the token itself. Then right below that, I'm adding a security requirement. This tells Swagger, hey, you need a valid bearer token to access any secured endpoints. And with this setup, we'll be able to enter our token once in Swagger, and it'll be used automatically for all secured API calls during testing. Super handy, especially while developing. While we're here, let me quickly show you how these changes actually affect Swagger in practice. Alright, here we are. If you take a look at Swagger, you'll notice this little Authorize button at the top. When you click on it, a pop-up shows up where you can paste your JWT token. Just type bearer, followed by a space, and then your token. This allows Swagger to send the token along with your requests, which means you'll be able to access secure endpoints, the ones that require authentication. Now, of course, at this point, we haven't actually created any secure endpoints yet. We'll get to that in the next steps. But once we do, this is how you'll test them right here in Swagger. And that's it. Our API is now ready to authenticate users using JWT. Let's move on to the next step. But before that, it'll commit all the changes. Okay, the first step is done. Now, let's move on to the service layer and update the login method. We'll also create a new user service to handle authentication using our new token system. There we go. I'm going to update the login method to generate a JWT token when a user logs in successfully. First, I'm using User Manager to find the user by their email. At this point, we're 100% sure the user exists because the login was successful. So next, I'm going to create a list of claims. And as you probably know, claims are just pieces of information about the user that we include in the token. Here, I've added two claims, one for the user's ID and one for their email. These are super useful when we want to identify the user on the back end without hitting the database every time. Once we've got the claims ready, I simply pass them to our generate JWT token method, the one we just built in our token handler. I just need to inject the token handler into the class. Now, once the token is generated, we've got a fresh JWT token ready to be sent back to the client. But instead of returning just the token on its own, I'm wrapping everything in a response model. If you've been following the previous parts, you've already seen this model in action. It helps us keep all responses consistent across the app. The response model includes three key parts. Is success, which I've set to true. A message, here it's simply login successful. And data, which holds the actual user profile. Now for the data, I'm creating an instance of application user profile view model using the user object, and then assigning the generated token to its token property. So in the end, the client receives both the user's profile and their access token, all bundled up in a clean and predictable structure. Obviously, the interface needs to be updated as well. Alright, now I need to update the return object for cases where the sign-in isn't successful. Just like the successful case, we'll still return a response model that wraps around user profile view model. But this time, the isSuccess flag will be false, the error message will stay the same as before, and the data will simply be null. Now let's jump over to where this method actually gets called, and that's in our login endpoint in the API project. There's just a small change here. We only send the response back to the client if the login is successful, and that's it. Everything's looking good here. No extra changes needed. Alright, now to keep things consistent with our API project, I'm going to create a folder called Identity here in the service project as well. I like to keep a similar structure across projects because as things grow, it really helps to find classes more easily, especially when the solution gets bigger and bigger over time. Okay, next I'm moving the authentication service and its interface into the Identity folder, just keeping things organized. We don't need the old folder anymore, so we can safely delete it. Now I'm adding a new class called User Service. This one is public, and it implements the iUser service interface, which I'll create right after this. Also is public. Inside the interface, I'm defining two methods, update user profile and change password, and we'll implement them shortly. Now let's create the user controller in the API project. I've already prepared the code, so I'm just going to paste it in here. Nothing new except one important detail, the authorize attribute at the top. This little attribute means that all the endpoints in this controller are protected and only accessible to authenticated users. In our case, that means users with a valid JWT token. Pretty cool, right? Everything we've done so far, generating tokens, setting up authentication, it all leads to this point. Now we can start building secure endpoints that only logged-in users can access. Since I'm already passing the input model to the service, I'm just going to copy that over to the interface. Same goes for the change password method. Gotta keep things in sync. Now, since this controller is secured, we know for sure the user is authenticated, which means I have access to the user object with a capital U. This gives me direct access to the claims inside the JWT, like the user ID, and that's exactly what I need to pass down to the service layer. In ASP.NET Core, user represents the currently authenticated user. It's part of the controller base class, and it gives you everything you need about the user, their identity, claims, and authentication details. So whenever you're inside a controller and need to grab info from the JWT, user is your go-to object. Now I'm going to pass the user ID to the update method. That way, the service knows exactly which user needs to be updated. But actually, instead of just passing the user ID, I've got a better idea. Let's make this a bit more future-proof by creating a model that holds both the user ID and the email. And later on, we could easily add more properties, like tenant ID or whatever else we might need. So inside the identity model folder in the model project, I'll create a new class called application user context. For now, it'll just include the user ID and email. Simple and clean. Alright, now instead of passing just the user ID, I'll pass this application user context model to the service methods along with the input model. This gives the service layer all the user info it might need. I'll do the same thing for the change password method too. And of course, that means updating the interface to match. Okay, with that out of the way, it's time to implement the user service methods. I've already written the code, so I'm just going to paste it in and then walk you through how it works. Starting with update user profile. The first thing I do here is check for nulls. I make sure we've got the user ID and that the first and last name fields are not empty. If any of these are missing, we throw an exception right away. In the future, we're going to implement a logging middleware that catches and logs these kinds of exceptions automatically. That way, if anything unexpected happens, like a missing user or invalid input, we'll have a full record of it stored in the database. This is super helpful for maintaining the app, especially as it grows, because we'll be able to trace issues more easily and fix bugs faster. Okay, next, I use the user ID from the user context to fetch the user from the database. If the user isn't found, I throw an exception, because something definitely went wrong at that point. This exception is very unlikely to happen, because remember, the user must already be logged in before reaching this method. But just in case something strange does occur, it doesn't mean we should send a detailed error message back to the client. Why? Because not all exceptions should be exposed. Sometimes, what's happening behind the scenes isn't part of a normal user flow. It could be something unexpected, or even suspicious. So instead of showing a message to the client, we just log it internally and move on. This helps protect our app and avoid giving away too much information to potentially bad actors. Once we've got the user, we update their first name and last name. And if the optional fields, date of birth, gender, or image name are provided, we update those too. After that, we call usermanager.updateAsync to save the changes. Then, we return a response model of type Boolean, with a success flag and a message saying whether the update was successful or not. Now let's take a quick look at change password. It follows a very similar structure. We check for null values first, user ID, current password, and new password. Then, we fetch the user by ID and try to change the password using usermanager.changePassword. Again, the result is wrapped in a response model to keep things consistent with the rest of the app. And we return a message based on whether the password change succeeded. So both of these methods follow a clean and predictable pattern. Validate input, fetch the user, perform the action, and return a consistent response. Makes debugging and future maintenance much easier. If you remember, both the change password and refresh token endpoints were originally added here by Copilot. Now, we don't actually need the change password endpoint in this controller anymore, so I'm going to remove it. As for the refresh token, I'll leave it here for now. We're not covering it just yet, but in the next episode, we'll dive into how it works and implement it. Step 2 is now complete. Nice progress so far. Next, we'll shift our focus to the internal services inside the Blazor web project. Later on, we'll refactor this part into a shared service project, so it can be reused by both our mobile app and the web app. But for now, we'll keep it local. In this next step, we're going to update the login method, create a user service, and also introduce a new service class dedicated to error handling. Alright, let's get started. Just a quick reminder. Earlier, we updated the login method in both the service layer and the API so that instead of returning just a Boolean, it now returns a full user view model along with the token. Well, here in our internal service layer, we need to apply the same change, so I'm heading over to the authentication service class to update the login method. Just like before, we're changing the return type from bool to our application user profile view model. And of course, don't forget to update the interface as well. Now, let's talk about the handle error response method. Up until now, this method returned a response model with a bool inside these angle brackets. But since we're now dealing with different types of data, sometimes a user view model, sometimes something else, we need to turn this method into a generic one. Here's the change. We make the method generic like this. Instead of using bool, I use a capital T right here between the angle brackets. Also, I add the generic type parameter right after the method name. The second T in the method signature tells us that handle error response is a generic method. That means we can specify the type it should handle when we call it. This gives us the ability to dynamically work with different return types, whatever we need at that point. Now, wherever we call this method, we also need to pass in the expected data type, whether that's a built-in type like bool or a custom class like application user profile view model. This change gives us much more flexibility and helps keep everything consistent and type-safe across the app. Alright, since I want to use the error handling logic in other services as well, it makes sense to separate it out from the authentication service and create a dedicated service for it. I name it Error Handling Service. So I'm cutting these two methods and moving them to the new class. The handle error response method shouldn't be private anymore, so I'm changing it to public. I'll also inject the localizer into this new service, and of course, this class will implement its own interface. Let's quickly create that interface too. Everything looks good so far. Now, back in the authentication service, I no longer need the localizer. I inject the new error handling service instead. I'll also make some small changes to call the method from the new service instead of having it inside this class. And finally, I'll register the new service in the DI container inside program.cs so it's available throughout the app. Now let's get back to the main task, updating the login method. If the login endpoint responds successfully, it means the API returns a response model that includes a user view model. So I deserialize the JSON response into an object. Then I check a few things. The result should not be null. The operation should be successful. Result.is success. If all those conditions are met, that means we've got the user profile. Now, using JS runtime, I store the user profile in local storage so we can use it in the next and final step. We've already worked with local storage before. Remember when we stored the dark mode and culture settings in the earlier episodes? To do this, I also need to inject IJS runtime into the service. And this return should go inside the same if condition to make sure we only return the user profile when everything is valid. And result.data, which is our user profile, shouldn't be null either, so I'm adding that to the if condition as well. Alright, now I'm adding a new folder called identity here as well, just to keep the structure consistent with what we already have in the service layer and the API layer. Next, I'm moving the authentication service into this folder, so everything related to identity is grouped nicely. Now it's time to create the user service. And of course, I'll create its interface as well. At the moment, this service will have 3 methods. One for getting the user profile, one for updating the profile, and one for changing the password. I've already written the code earlier, so I'll just paste it in here and walk you through the important parts. Let's take a look at the first method called getUserProfile. First, we're using JS runtime to read the user data from local storage. We're specifically looking for a key called user, which should contain a JSON string representing the logged-in user's profile. Then we check if that value actually exists. If it's not null or empty, it means the user has logged in before, and we can try to use their saved profile. Here, we deserialize the JSON string into our user profile model. This gives us access to the user's properties, like their token, username, and more. If the user object was successfully created, we go ahead and set the authorization header on the HTTP client. We're using a bearer token here, which is the standard way to authenticate API requests. Then, we return the user profile so the rest of the app can use it. And finally, if something went wrong or if no user was found in local storage, we return an empty user profile. This helps us avoid null reference exceptions later on in the app. So with this method, we're making sure that the app always knows whether a user is logged in, and if they are, we preload their data and set up their token for all API calls. These two methods you're seeing here are very similar to what we've already implemented before. They call their corresponding API endpoints, and they return the results based on the API response. If the request is successful, we return the proper response model. But if something goes wrong, we return the appropriate error message using our error handling system. Alright, we're not done with our internal services just yet. There's one more feature we need to add to the user profile page, and that's the ability for the user to upload a profile picture. Now, earlier in the project, we created a service called File Service. We originally used it to read email template files, remember? Well, now we're going to expand that service by adding 2 new methods, one for uploading an image and one for deleting an image. At this point, I can actually take advantage of a nice IDE feature. By clicking on Implement Interface, the method signatures will be auto-generated inside the class. Pretty handy. I'm injecting iWeb host environment, so I can safely get the actual path to the www root folder or any other content root in a clean and environment-independent way. When your app runs, especially in production, the working directory might not be what you expect. It could be different from what you see during development. That's why we use iWeb Host Environment, to make our file paths safe, dynamic, and ready to work reliably across all environments. Next, at the top of the class, I'm going to define two fields. One that lists the allowed file extensions for images, like JPEG, PNG, etc. And another that sets the maximum file size allowed for profile pictures. This helps us restrict uploads and prevent abuse, or users uploading giant image files by mistake. I paste the code inside the method. The upload method needs to be asynchronous. For those of you who aren't too familiar with async and await yet, I highly recommend spending a bit of time studying it. It's super useful when dealing with I/O operations like file uploads or network requests, and it keeps your app responsive. Okay, this method takes in a file uploaded by the user via Blazor's iBrowser file and a container name, which is basically a subfolder where we want to store the image. First, we check if the file is too large. If it exceeds our predefined size limit, we throw an exception right away. No need to continue processing something we won't accept. Then we validate the file type. We only want to allow specific image formats, like JPEG, PNG, and so on. If the file type isn't in our allowed list, we throw another exception. Next, if the file is larger than 1 megabyte, we resize it before storing. We use the built-in Blazor method requestImageFileAsync to shrink the image down to a maximum of 500 by 500 pixels while keeping the same format. We then create a memory stream and copy the contents of the uploaded file into it. This gives us access to the raw file data, ready to be saved. Now we get the file extension, like JPEG or PNG, and generate a unique file name using a GUID. This ensures we won't overwrite existing files and keeps things nice and safe. Just to be extra safe, we check the file name to make sure it doesn't contain any invalid characters. If it does, we stop the process and throw an exception. Next, we build the full path to the destination folder. We combine the www.root/images folder with the container name passed to the method. If that folder doesn't exist yet, we create it. Finally, we build the complete file path and save the image to disk using file.writeAllBytesAsync. If everything goes smoothly, we return the file name so we can store it in the database or use it on the UI. And if anything goes wrong at any point, we catch the exception and throw a generic application exception with a simple message. So in short, this method safely uploads a user image to a specific folder, makes sure the file is valid, resizes it if needed, and returns the final file name, ready to be used in our application. Once the upload is done, I'll also complete the delete method. And yep, this one also needs to be asynchronous, since file operations often rely on I/O. Alright, now let's take a look at the deleteImageAsync method. This one's responsible for safely removing a previously uploaded image from the server. Since we don't want to keep the old image when a user uploads a new one, this method helps us keep things clean and up to date. It takes two parameters: the name of the container, which is basically the folder the image is stored in, and the file name of the image we want to delete. The first thing we do is a quick validation. We check if the file name is empty or contains any invalid characters, just like we did during upload. If the name is not valid, we stop right away and throw an invalid operation exception. Next, we build the full path to where the image should be. We start by combining the web root with the images folder and the container name. Then we combine that with the file name to get the full path to the image file on disk. Now we check if the file actually exists. If it does, we delete it. But here's a little trick. Since file deletion is a blocking operation, we wrap it inside task.run to keep it asynchronous and non-blocking for the rest of our app. If the file wasn't found, we throw a file not found exception with a helpful message, including both the file name and the container name, just in case we need to debug it later. And like before, we wrap everything in a try-catch block to handle any unexpected errors. If something goes wrong, we throw a generic application exception with a clean, user-friendly message. So this method makes sure we only delete valid image files. It safely checks if the file exists and handles errors gracefully, all while keeping the operation asynchronous. Alright, step 3 is done. Now let's move on to the final step, step 4, where we actually bring everything we've done so far to life on the screen. In this step, we're going to build the user profile page so we can finally see all our work in action. We had already created the user profile page, which initially only included a simple title. Now that we've added more content to it, let me walk you through the structure and key parts of this page. Just like our other Blazor pages, this one begins with a route declaration at the top using the @page directive. This tells Blazor which URL should display this page. So, whenever a user navigates to that URL, they'll be taken directly to the profile page. I've also injected the necessary services and objects that this page will use. Among these injected services, only the snack bar is new. It's used to display messages to the user. The rest were already used in our previous files. This page is divided into two main sections: Profile Summary section and Tab section. Profile section, which is like a card container at the top. Here is the user's avatar, inside a mud badge. The badge shows a green color if the user is active. There's also a file upload component, allowing the user to upload a new profile image. When they do, the upload image method gets triggered. The user's full name and email address are also shown in this section. The rest of the page is organized into 3 tabs. User Details panel shows the user's information from the view model. Nothing too complex here, but we do check the user's activity status and show a different visual style if the user is active or inactive. Edit Profile panel, similar to the registration page, but embedded in a panel. The user can update their first name, last name, gender, and date of birth. Changes are stored in an update model, which will be sent to the internal service and API. Change Password panel. This panel includes 3 input fields: current password, new password, confirm password. All fields are validated, including password matching, which is handled using a custom function called password match. Submitting this form triggers Submit Form Change Password, which updates the password if the input is valid. It uses its own model called Change Password Model, which was already added to the Models project, as well as Update Model. Both the Edit and Change Password panels have their own custom error display components. For these components, I've set the elevation to 0, so they appear without borders, giving them a clean look. Let's move on to the code section. These are the ones we've had before, and you're familiar with them. This is a constant string. It's used to define the folder name where user profile images are stored. Another constant string. It defines the default profile picture file name. This image is used when the user hasn't uploaded their own profile picture. This is a static method that builds the relative path to an image file. It uses string interpolation to dynamically insert the folder and file name into the path. String interpolation offers a cleaner and more readable way to format strings compared to traditional methods. If you'd like to learn more, you can check out the official Microsoft documentation. I'll include the link in the description. This sets a private variable called image src to the path of the default avatar image. It uses the static getImagePath method and passes in the default avatar constant. As you know, this method is part of the Blazor component lifecycle and is called after the component has rendered. It's useful for running logic that depends on the component being visible on the screen. Those who follow this series know that we are already familiar with this. This condition ensures the logic inside only runs once, right after the first render. That way we don't keep fetching the user profile every time the component re-renders. We set a loading flag to true or false, to show and hide a spinner while data is being fetched. We fetch the user's profile data using the service layer. The result is stored in ViewModel. If there's no token, it likely means the user is not authenticated, so we redirect them to the login page. We check if the user has a profile image. If not, we use a default avatar. If yes, We generate the full path to their image using a helper method. We copy values from the view model, the data we fetched, into the update model, which is used for editing the user's info. We handle gender selection by getting the gender from the fetched data. If it's null, we use an empty string. This line tells Blazor to re-render the UI now that we've updated the component's state. This is a private asynchronous method that handles the uploading of a new profile image when the user selects one. It also updates the user's profile with the new image and cleans up the old image if needed. We upload the selected file using the file service. It takes two parameters as method arguments. File, the new image selected by the user. Image container, the name of the folder where we want to save the image. The uploaded image's name is stored in the update model. Next, we update the user's profile on the server with the new image name by calling the service layer. We set the image src to show the new image by generating the correct file path. If the user already had a custom image, not the default avatar, we delete the old image from the server to free up space. Then we update the view model so the UI reflects the new image. If something went wrong during the profile update, we show an error message using the snack bar, a small pop-up notification. This method is triggered when the user clicks the Save button on the Edit Profile form. First, it validates the form. If the form is not valid, the method stops immediately, updates the gender value in the update model based on the selected option in the UI, sends the updated info to the server using internal service. If the update is successful, we show a success snack bar message. If there's an error, we store the error message to display it in the error display UI. This method handles the password change form submission. Again, validates the form. If validation fails, we stop right there. Sends the password change request to the service using the filled out model. If it works, we show a success message. If it fails, we store the error in an array, so the UI can display it near the form in the error display component. The rest of the methods are ones we've already covered before, so I don't think they need further explanation here. They're pretty straightforward and self-explanatory. Okay, let's add our user service and configure those nice-looking snack bar notifications. I'm opening program.cs now. And right inside the service configuration, we'll add these two essentials. This is where we set up how snack bars behave in our app. Newest on top, false, means when multiple messages come in, new ones stack at the bottom, just like how we naturally read from top to bottom. We're enabling the close button because, well, sometimes users want to dismiss messages immediately, right? We're allowing duplicates with prevent duplicates, false, because if someone gets the same error twice, we should probably show it twice. Might be important. Each message will stay visible for 10 seconds, long enough to read, short enough to not be annoying. And we've got nice half-second fade animations so they appear and disappear smoothly. We're using the filled style to make these notifications really pop visually and positioning them in the bottom right corner, out of the way, but still noticeable. This is one of those configurations you'll tweak as your app grows. Maybe shorter durations for success messages, longer for errors. You get the idea. Now that we've got this set up, our users will get clear, polite feedback whenever something happens in the app. Let's save this and see it in action. Alright, let's test our token flow. I'm going to log into my account first. Before we proceed, let's peek into local storage. Yep, there's our token, safely stored. Now, let's try changing our profile avatar. Whoops, that error message is actually helpful. Our snack bar is working. See that? The system caught that I forgot to register the user service in our API's DI container. Let me quickly fix that. Right after the authentication service. There. No need to re-log in since our token is still valid in local storage. Wait a second. I just said our token is still valid, but what happens when it expires? I want you to try something. When you're practicing with this code later, pay special attention to what happens when the token expires. Experiment with it, and think about how we might handle it. What solutions come to mind? Don't stress though. I'll be covering this exact scenario in our next episode, or small follow-up for this episode. We'll implement a proper token refresh flow together. For now, just enjoy watching it work perfectly while our token is still fresh. Let's retry that avatar change. And success. Beautiful. Now let's test profile updates. Switching to the Edit Profile tab, I'll just change the first name, last name, gender, and date of birth. And there's our success snack bar. Perfect. Final test. Password change. Entering current password. New password. Confirmation. Securely updated. Now to test Swagger with token. Click Authorize button. Type bearer, then space and insert token. Now Swagger will include this in all requests. Let's test our secured user controller endpoint, the one with the Authorize tag. Changing the name fields again. Execute. And we get back a happy 200 OK response. Quick database check. And yes, the changes are persisted. We've wrapped up step 4, and everything's running smoothly. The token's being validated, changes are saved, and our trusty snack bar is delivering those sweet success messages. Mission accomplished. In today's episode, we implemented the token handler, built the user controller, user service, and the user profile page, along with a few other key updates behind the scenes. In the next video, we'll implement the refresh token feature so your access token can be automatically renewed. No more logging in again after it expires. Oh, and don't forget, I create a short Google Form quiz for each episode to help you review what you've learned. You'll find the link in the episode description. Give it a try. See you in the next one. And as always, happy coding.